Hello everyone. Today we will be solving educational round 169D colored portals where you are given n cities and each city has a portal. There are total 4 colors of portals: blue, green, red and yellow. You can move from city I to J if you have portals of same color. Like let's say in 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 one city you have blue green and in another city you have green red, so green green is matching. Then therefore you can move from BG to GR. Basically, if there is at least one color in the portals that is equal to the different portal, then you can move from portal I to portal J, and you need to calculate the minimum cost to move from city X to city Y. Okay, so you are given n cities. Each city has two types of colors. Okay, you can move from one city to another city if there is at least one color matching. Else you cannot move through the cities. Okay, so now for the answer 1 comma 4 we have BR and GR. So red is one color that is matching in both the cities, hence we can directly go from here to here and the answer would be directly I minus J, which is 3. Now if you look for this case, when you want to move from GY to BR, then you cannot move directly from GY to BR because there is not one color that is matching. But if you move from GY to GR, that is possible because GG is same. Now if you move from BR to GR, then it is still matching because RR is same. So from GY to GR 1 cost, then GR to BR 3 cost. Total 4 cost में you have moved from GY to BR. So you have to print the minimum cost to move from the cities X to Y. Now first case is so very easy. Like if in both the cities there is at least one matching color, then the answer is directly X minus Y. But what if it isn't? Okay, so I will show you how to solve the main case. Okay, there are 6 type of colors. Let's write it down: BG, BR, BY, GR, GY, RY. Okay, now we need to choose pairs such that all of the colors are different. It will be BGRY, BRGY and BYGR. Okay, so there are only 3 possible cases where you cannot directly move from X to Y. You will have to move in between some path. Now let's say you are moving from X to Y and you cannot directly move from X to Y. So let's say you are going X to A and then A to Y. Now in this problem, if we cannot go directly from X to Y, we will only need one intermediate. Why is that? Now let's say कि this is BR and this is GY. Now if this and this has a same color like R and G, then I can also match this with this, because if instead of one step I will choose 2 steps, like if I choose X to A to B and B to Y, so this would be very high cost and not recommended. Hence we will find how to go from X to Y using only one step. Okay, now since we have to go from X to Y using one step, we will use a block that has common values of X and Y. Like let's say we are finding how to go from BG to RY. So that means my step, if my step is BR, That means I can go from BG to BR and BR to RY. Then my step can be BY. I can go from BG to BY and BY to RY. Then my step can be RG. I can go from BG to RG and RG to RY. And my step can be GY. Okay. So I have 4 possible steps in between BG and GY. So I will check that out of all of these steps, which one is my most suitable answer. Now how will I choose that? Now I already know that my each portal is present in which all indices, right? So that gives me a chance of performing binary search. Okay, let's say we want to move from BG to RY and we have 4 possible midpoints: BR, GY, BY, RG. Okay, so now I want to find the suitable answer if I am using BR as my midpoint, which means BG to BR to RY. So what will my first priority be? If I find an index BR that is in between BG and BY, then that means the answer would be just RY minus BG, because if BR is between of both of them and this is X, this is A, this is Y, then my answer would be A minus X plus Y minus A, which is intent Y minus X. This is first case. Now second case. Second case, I will take A just before BG. Okay, like second case, A is less than X. So what would be my answer in that case? X minus A plus Y minus A. Okay, and now my third case. My third case is A is more than Y. Then what would be my answer of this case? A minus Y plus A minus X. Now we need to find these 3 suitable A's using binary search. How? I have all the indexes of BR, like where BR is present. If I want to find a value between X and Y, then I will query the greater or equal to key than X, and I will check if that key is less than Y or not. If it is, then that means I have got this first value. Next, I will find a key that is less than or equal to X. If the key is present, that is a suitable value of A. Then third key I will find greater than equal to Y. Then if this key is valid, then I will get a suitable answer for A. Okay. Now I will show you implementation. It is in Java, but I will convert to C++ and submit the code soon. Okay. And I will post the submission link in the comments. Okay. So first, these are all types of portals that I can have. I push its indexes. Now since I am pushing indexes, they are already in ascending order, which means I can easily perform binary search. Okay. Then I take L and R values. I swap them for min and max, because if I am going from 1 to 3 or 3 to 1, both are same. Okay. Then I search for a common side. If I find a common side, the answer is R minus L. Else, I will have to use my 3 terms: BRGY, BGRY, and BYGR. And the same thing reverse. Instead of BGRY, GYBR. And this both also reverse. Now, first I will take B and G, BG, B and Y, BY, R and G, GR, R and Y, RY. So these are my 4 possible steps, and I will find my answer for all of these. Okay. Now, if I want to find a key which is okay, this is my uh, user defined upper bound and lower bound functions. Upper bound function gives me greater than or equal to key. Lower bound gives me less than or equal to key. Okay, this is my implementation of upper and lower bound. Okay, so first I found the upper bound of L, which is greater than equal to key of L. If that is less than R, then this is one answer. Then I found less than equal to key for L, and then I find this answer. Then I found the greater than equal to key of R. Then I calculate the answer. Minimum of all of these answers is my final answer for that step value. Okay, so this is how, using each of these possibilities, you can solve this problem. The complexity for this is 4 into 3 into log n, which is 12 log n. Okay, so thank you guys for watching. Make sure to like, share and subscribe to never miss another tutorial.